So we have two requirements for a point of inflection. First, the second derivative equals 0. Second, the concavity around the coordinate changes. Now this is really, really important because most people finding a point of inflection, will find when the second derivative equals 0 and then completely forget about the second requirement there. Alright? So you need to remember that second requirement. It's necessary. Alright? You need to check that the concavity around the coordinate actually changes. You can't have a case where it's concave up and concave up again on either side of a point of inflection. That's not possible. Alright? It has to be concave down on one side and concave up on the other. So, how do you check if the concavity around the coordinate changes? How do you actually meet the second requirement? What you need to do is you need to plug in x values on either side of the coordinate and check if the sign, positive or negative, of the second derivative changes. Alright? So, let's go over this example here. We need to find any points of inflection on this curve. 7x cubed plus 2x squared. Right? First, we need to find the second derivative because that's our first requirement. Alright? So, let's find the second derivative. And then we need to find when the second derivative equals 0. So, our first derivative is going to be 21x squared plus 4x. Our second derivative is going to be 42x plus 4. Alright, now we need to find when the second derivative equals 0, so we're going to go 0 equals 42x plus 4. We're going to have negative 4 over 42 equals x. That should simplify into negative 2 over 21 equals x. Alright? So, this is satisfying the first requirement. We have checked where the second derivative equals 0. Now we need to see if the concavity changes around this coordinate. So when x equals negative 2 on 21, there's a concavity change. So what we need to do is we need to make a table of values with x and our second derivative. What we're going to do is we're going to put our x coordinate in the middle here, and then we're just going to chuck two random numbers on either side. Alright, this is kind of similar to the first derivative test that you do when you're trying to determine the nature of a stationary point, just in this table of values aspect. So, negative 2 divided by 21 is going to be a pretty small number. So how about we just do negative 1, a number that is smaller than that, and then 0, a number that's bigger. And let's pop in our second derivative value. So our second derivative was 42x plus 4. Alright, so when x equals negative 1, we don't actually, just like a tip, you don't actually need to know the value of the second derivative here, you just need to know whether it's positive or negative. So if you're in a calculator-free exam, which you usually will be when you're doing this, because I mean, if you had a calculator, you can just graph it, you don't need to do this. All you need to do is just kind of guesstimate, almost. So we're going to have 42 times negative 1 plus 4. Now, already I can tell that this is going to be a negative number, because 42 times negative 1 is going to be negative 42. The plus 4 is not going to cancel it out. Alright? it's too small. So I know that this is going to be a negative number. Now getting into when x equals 0. We know that this is going to be positive because 42 times 0 is 0 plus 4, right? So this means that the point we have found does satisfy the test, satisfy both requirements, because we have a concave down concavity here and a concave up concavity here. All right? So this is great. This is what we want. This means that we do have a point of inflection at x equals negative 221. So just for you guys, for your information, what you'll see if the second requirement isn't satisfied is you'll see a negative here and a negative here, or a positive here and a positive here. Like, it won't be negative 0 positive, it will just be a negative on either side, or a positive on either side, right? The concavity won't change, it will just be positive on both sides or negative on both sides. But here, because it's negative on one side and positive on the other, that means that our requirement is satisfied. So let's have a look at what our curve looks like. So as you can see, we have our curve having concavity that is concave down through here. It has a stationary point here. The point of inflection will be somewhere around here, all right, which checks out with what we found, negative 2 divided by 21. All right, so quite a small negative number. Makes sense that it will be in here, and then it is concave up here. So this is also checks out with what we found here. We found it was concave down on the left-hand side of the point of inflection, and then concave up on the other side. So we have concave down, point of inflection, concave up. All right.